Dear students, in my previous discussion, we were discussing the testing the hypothesis of the sampling technique, and the next concept on the same line of continuation is level of significance. In this level of significance, what we consider at three important observations. One is the probability level below which we reject the hypothesis is known as level of significance. That means for any given data, first we claim some kind of proposition that is regarded as hypothesis, that is going to happen or not going to happen. In this way we propose some identity or we propose some claim. If that claim happens in favor of us, then we are going to declare some result, and if it is not going to fall according to our claim, then we are going to declare some other result. But here the level of significance, how it takes two types of regions, we call them as critical region. The region in which a sample value falling is rejected is known as critical region. In this, two important numerical values we discuss generally, that is 5% and 1% areas of normal curve. That means in the discussion of the normal curve, that is the area under normal curve is covered, it is called as a bell shaped curve. Sometime back I was explaining about the normal curve area like that, and the critical regions. In this normal curve, as you know that the three numerical values will coincide. One is arithmetic mean of the given series is the same as median of the given series is the same as mode. That means from the central ordinate on either sides the data is distributed equally. We consider this region for our declaration of the testing the hypothesis of the given total sample in the form of two regions. One is that is 5% and another one is 1%. What exactly we mean by these 5% level of significance and 1% level of significance? That is, the shaded portion in the figure corresponds to 5% level of significance. That is 5% means we must fix certain numerical values on either sides of the bell shaped curve. We call it as a symmetric curve. That is referring to two numerical values, that is 1.96 towards the positive direction and minus 1.96 towards the negative direction of this normal curve. And here, if that is the case, for example, if this is minus 1.96, if this is plus 1.96, then this discussion means discussion under this area covering between minus 1.96 up to plus 1.96 gives the declaration with a reference to 5% level of significance. And similarly, another one is this we have taken in the figure like, that is up to the first limit, minus 1.96 and another one is plus 1.96, and outside this minus 1.96 and plus 1.96 we extend up to 2.58 to the positive direction and minus 2.58 to the negative side of the central ordinate of this standard normal curve, and we take these two regions again the second critical region. That means first critical region we take, that is minus 1.96 up to plus 1.96, and the second critical region we consider that as 2.58 with minus sign and plus sign 2.58. That is another critical region respectively. That is 1% for 2.58, and if the curve is extended up to here and if the curve is extended up to here, this is 2.58 to the right side and minus 2.58 to the left side. This gives in association with declaration of 1% level of significance. Why these two values we consider, because practically in many of the application situations we come across to take whether we have to accept the hypothesis which we propose for the given sample, or we have to reject the hypothesis for the given sample in these regions. Then testing of significance for these two regions. Here it enables us to decide whether to accept or to reject the hypothesis, and the difference between these two populations, how they behave, to what type of fluctuations this sample data will behave. That is the decision which we have to take under the confidence limits. Those confidence limits are, as I told you, that is mu. Mu means it is population mean, and minus of 1.96, this is the standard deviation sigma, and mu plus, that is 1.96, that is standard deviation towards the right side. Mu plus means in general we call it as, that is arithmetic mean plus 1.96 into the into multiplication by standard deviation, and that declares about 95% times the declaration of testing the hypothesis. And similarly, the another result which we can declare as, that is 2.56 to 58, that is S plus or minus 2.58. That is, first one is mu plus or minus 1.96 sigma, and the another one is S plus or minus 2.58 sigma. That is, mu means there it is population mean plus or minus 1.96 into standard deviation, and here S plus or minus means sample mean plus or minus 2.58 into standard deviation. So these two values will help us, these two values will suggest us how the hypothesis which we propose for the given type of application situation, whether we have to accept or to reject. Then simple sampling of attributes. Here the sampling attributes may be regarded as selection of samples from a population whose members possess the attribute K or not K. That means it is called success, or its absence as a failure. That means success is not there, means obviously we take it as failure. Then the probabilities in terms of binomial distribution. In the previous discussion I was telling, in the form of binomial discussion means that is a plus b whole to the power n will be taken respectively. A stands for probability of success, and then in place of p. That means here printing mistake is there, that is to be written as q, that is p plus q whole to the power n, where that is q is equal to, that means probability of failure. As you know the concept, that is p plus q is equal to 1. What do you mean by this p? P is nothing but the basic mathematical priority definition is nothing but p is equal to number of favorable cases divided by number of exhaustive cases. I hope you got complete meaning. You are much familiar with the numerator, how we are going to write number of favorable cases and number of exhaustive cases. That means when you are given n number of equally likely and mutually exclusive and exhaustive. That is, out of which how many cases are going to favor us, and it is taken as a ratio calculation, number of exhaustive cases. That is the value of p. What do you conclude about the p? P stands for, that is probability of an event to happen, it is a success. Then q means that is equal to opposite, means success is not there, means it is a failure. Then p plus q is equal to 1 means p is equal to 1 minus q and q is equal to 1 minus p. Obviously you know these numerical values, that is 0 less than or equal to p less than or equal to 1 and 0 less than or equal to q less than or equal to 1. Keeping all these things in our idea, then You can use binomial theorem, you can use Poisson's distribution, you can use normal distribution, but in all these theoretical distributions we consider the basic concepts of all these probability in the declaration of the testing the hypothesis by choosing that is standard deviation as the constant of binomial distribution. There are two constants of binomial distribution we know, and first constant is arithmetic mean given by n into p, and the second constant of binomial distribution is that is root of n into p into q. That means through using the given number of values of n and the probability which we calculate for the given data and the probability of failure which we calculate from the given data. Using these statistical parameters we can decide the decision or final decision whether the hypothesis is to be rejected or the hypothesis is to be accepted. Now, here in terms of the proportions, if we consider the proportion of success, then the proportion is given by the mean proportion will be n into p divided by n cancels, then resulting as p, and the standard error of the proportion of success is given by, in place of npq, that is second constant of binomial distribution, divide each probability value by n, that is here this one, this is p divided by n and q divided by n, and one n cancels, and as a result you are getting the square root of pq divided by n. Then the precision of proportion of success is given by the reciprocal of above, what we calculated as square root of pq divided by n will be written as n divided by, that is p into q, which varies as square root of n, since p and q are the numerical values we call them as constants. Then here, based on all these observations, then we go for when the data is normally distributed. Under this principle, we are going to discuss different situations. We can take them as problems. The first commonly occurring problem, like commonly occurring situations we can come across. A die was thrown 9,000 times and a throw of 5 or 6 was obtained 3,240 times on the assumption that a random throwing do the data indicate an unbiased die. The situation is like this: the die was thrown 9,000 times and a throw of 5 or 6 was obtained, that is 3,240. That means this value, that is 9,000, is what I told like n, that n stands for, that is total number of exhaustive cases, that means total number of outcomes. When, as you know, the die is nothing but a small cube, and marked on each surface in terms of dots, that is from 1 to 6 dots are there. Then how many times we throw this die with unbiased condition? You must remember, any situation we take, either we toss the coin or tossing the coins, either we throw the die or more than one die. If you consider 2 dice, 3 dice, 4 dice like that, if you throw them with the unbiased condition, or if you choose the card or cards from the pack of cards or packs of cards, and the ball which you are going to choose randomly from a bag where different colored balls are mixed, like that. These are the commonly occurring examples, and then how this testing the hypothesis we are going to consider under the confidence limits. That is the problem's purpose here. This problem purpose is here. Then we throw this die, single die, for totally 9,000 times. Now, a throw of 5 or 6 was obtained, how many times? That is 3,240 times. Dear students, what you have to understand here is, what is the probability of throwing 5 from a single die from a single throw, and what is the probability of throwing 6 from a single die from a single throw. Then here, as you are aware, that is a throw of 5 or 6 was obtained. That means throw of 5 or 6 is nothing but application of addition theorem on probability. That is, there is a choice of expecting phi on the upper surface and expecting phi on the upper surface, expecting 5 on the upper surface and expecting 6 on the upper surface, not both at a time, but once 5 you are getting, another time 6 you are getting. What do you mean by that probability? For example, you can assume this itself as die. You assume that it is not exactly each surface dimension is equal to each other. You assume that this is a die because you can imagine that on this surface 1 dot is there, on this surface 2 dots are there, on this surface 3 dots are there, like that on every surface from 1 to 6 dots are indicated. Then I am throwing this die for 9000 times. Yes, what is the probability of getting phi from this die? That means P of getting phi in a single throw is equal to how much? Out of, that is 1 to 6 means 1 divided by 6. Similarly, getting 6, another one, P of getting 6 is equal to, that is also 1 by 6. Single throw of a die. How many times you are getting phi? Only one time. But how many total possibilities are there? There are totally 6 possibilities, because when you throw this one, any surface can fall on the upper surface, right? So on that upper surface, I need phi, then I need 6. Then getting phi is 1 by 6, getting 6 is 1 by 6. Then by the theorem which you studied as choice means addition theorem, that is probability of getting 5 or 6 is equal to P of phi plus P of 6. How we are writing this equation? Because these two events, that is each event is independent, that is P of getting phi is nothing to do with P of getting 6, and similarly P of getting 6 is nothing to do with, that is getting phi. Therefore, these two events are mutually exclusive. That means occurrence of one event does not depend on the occurrence of second. Therefore, here this is the probability value 1 by 6 and plus 1 by 6, that is equal to 2 by 6 and that is equal to 3. What do you mean by this? Simply you can represent this one as probability of getting 5 or 6 is nothing but this is simply P. This is called success of getting 5 or 6. This is done by simple example, simple concept, that is addition theorem. Then that's what here, that is n equal to 9000 you can consider, and 5 or 6 it is given out of 9000 times is 3240. It's the given value. Then we consider this one as observed value of successes. What are those successes? We are getting probability of getting on the upper surface as 5 or 6 out of 9000 times. This is observed value. Then what we are going to declare in terms of probability, getting 5 or 6 in terms of probability for a single throw in a single die, it is 1 by 3. Then obviously the value of failure, that is Q is equal to 2 by 3. Then the expected number, that is probability into the total number, that is 1 by 3. 1 by 3 into 9000, that is equal to 3000 we take. Then the standard normal variate. The standard normal variate means that is the bell shaped curve. This curve is nothing but PR is equal to 1 divided by sigma square root of 2 pi and e to the power minus z square by 2. What is that? What is that z? Z is nothing but x minus x bar divided by standard deviation. What do you nomenclature this term? This has been nomenclatured as standard normal variate. This standard normal variate will decide the value of the ordinate where exactly it comes on the x-axis. That means these are all the ordinates where we come across, that is 1 sigma, this is 2 sigma, this is 3 sigma, like that towards positive direction, and minus 1 sigma, minus 2 sigma, minus 3 sigma, to the left side of the central ordinate of the normal curve. Then this term or this calculation decides whether the from the given data the ordinate lies towards the right of the central ordinate or towards the left of the central ordinate. Then we consider the area under normal curve, and then further what is its stable value we consider from the standard normal area values from the table it is available, and then we further calculate the value of probability density function or probability mass function. Here we go for standard normal variate as, that is z equal to mean, that is sample mean minus population mean divided by, that is standard normal variate. That means here in terms of mean means, that is x minus np I consider and divided by standard deviation. That is the observed number of successes is equal to, that is the arbitrary given value, that is 3240 minus 3000 divided by square root of 9000, that is square root of np cube, like that. That means standard deviation here, that is x minus n into p divided by sigma, that is square root of n p cube. What do you mean by these two values? These two values are called in the binomial distribution, that is binomial distribution, as I told you that NCR, it is q to the power n minus r and then p to the power r is there. For this there are two standard values, two constants of binomial distribution. They are namely, one is mean, that's equal to x bar, that's equal to n into p, and the another one is, that is standard deviation, sigma is equal to root of np cube. I am sure that you are much familiar in deriving these relations in theoretical distributions topic. Then from there I borrow these things and then I will make use in giving the value of this z. Therefore, in place of x bar I put it as np, and in place of sigma, that is standard deviation, I put it as square root of npq. For me now all these values are available because this x is 3240, it is the observed number of success, then I will write as it is. (3240) minus n into p. You can directly write as it is. N means it is 9000 into p value, that is p means 1 by 3. What is that 1 by 3? Probability of getting, so by a single throw like 5 or 6 on the upper surface, that is 1 by 3 divided by square root of, that is npq. N is again 9000 into 1 by 3, and here you have to put it as q, that is q means 2 by 3. Q means it is 1 minus p also you can write, then comes to be 2 by 3. So what is this value will decide what we discussed about the critical regions for declaring the hypothesis is to be accepted or to be rejected at what level of significance. Here this calculation comes to be, that is 5.4, this is equal to 5.4, and we have decided minus 1.96 and plus 1.96 is one critical region, and minus 2.58 and plus 2.58 is another critical region. Dear students, you can decide very easily now what is the value of calculation of z, that is equal to 5.4. It does not match with both the values, then even 2.58 it exceeds. That means 2.58 is our limit which we fix, but here we are getting it as 5.4, which is greater than 2.58. This shows that the hypothesis is to be rejected at 1% level of significance. As you know that 1% level of significance is referred to minus 2.58 and plus 2.58. It is beyond that range. What we calculated now, it is 5.4. Easily you can declare that the question in this is, a die was thrown 9000 times and a throw of 5 or 6 was obtained 3240 times on the assumption of random throwing. Do the data indicate an unbiased die? What is your conclusion then? It must be not an unbiased, but it must be a biased die. A biased die means it is not properly the random experiment is conducted. The die final declaration or conclusion, we can say the die is biased. Similarly, another situation we take a sample of 900 items as the mean, that is 3.4. Let me record all these values. This is another situation where some important information is there in this situation. I am going to talk about the final declaration, final conclusion of the hypothesis what we are going to propose in this situation. A sample of 900 items has mean of 3.4, then simply represent mean as 3.4 in the solution. Afterwards the meaning we will attach. Then population mean, that is standard deviation, it is given sigma, it is standard deviation 2.61 and the next value it is given. Can it be regarded as drawn from a population with mean 3.25 at 5% level of significance? Everything is clear in this situation, but this type of data was not in the previous situation. Here, there it was a probability value which you were supposed to calculate, and then you were supposed to write the value of population mean. But here all those values are given in this directly in the statement itself. Then you have to calculate the values of value of that z, and you have to declare whether the hypothesis is to be accepted at 5% level of significance or not. Now, what is the population mean? That population mean mu we take, that must be 3.25. Then what is the level of significance it is to be checked? At 5% level of significance. Once again, you take this standard normal variate expression, and in that expression z equal to, that is x minus x bar divided by sigma, that is equal to, here it is x minus x bar divided by sigma should be, it is 3.4 sample mean, we consider that as a first term, and population mean, that means this will be chosen as sample mean and this is a population mean. That means you can consider x as minus x bar in terms of mu divided by sigma. Any notation you can use. That means 3.4 minus 3.25 and divided by, it is 2.61. Here this is the value of z. Then here the value of z comes to be 1.73. Anyway, in any situation, if you come across with negative value, then modulus value you have to take, because all these are the measurements are taken in the positive sense, that is 1.73. Here this level of significance, it is given as 5% and it is less than even 1.96 also. Then when it is less than 1.96 itself, the given sample can be regarded as one of the population with mean 3.25, because it comes below the table value. Table value means it is a standard critical region at 5% level of significance. 5% level of significance means this is nothing but between minus 1.96 and plus 1.96 range. This is one critical region. So 1.73 less than 1.96, which comes in between these two. Therefore, it is not unbiased, and the sample which gives the conclusion as it is one of the populations which is given with the mean as 3.25. So, the given numerical value, the mean as 3.25 as the population mean can be accepted. This is what the hypothesis that you have to declare. And similarly, another situation, this is of different type of again data. A sugar factory is expected to sell sugar in 100 kg bags. A sample of 144 bags gives the mean as 99 kg and standard deviation as 4, can we conclude that the factory is working as per standards? This is a simple question and simple data is there, but in the conclusion you have very good information that you have to declare whether the claim, the factory which is expected to sell sugar in 100 kg means when you go for testing the sample, all the bags what this sugar factory is selling the sugar, whether they contain 100 kg or less than 100 kg. Anyway, anyone cannot expect more than 100 kg. That means if he wants to show some biased application, then whether he sells every bag with the exact weight or the weight which is less than 100 kg, then the data goes like this. For this, it is given what is the value of n. Here you have to take sample, that is 144. That means n equal to 144, and what is x bar, what is mu, and what is the percentage of level of significance we have to take. Then sample mean, it is given as 99, and the population mean, that is sample mean minus population mean is declared one is 100 kg. Then you have to consider the standard normal variate, that should be 99 means sample mean minus population mean divided by standard deviation, that is square root of 144. Therefore, then it is square root of 144 and the standard normal variate z value, that is comes to be like the modulus of z equal to 3, and this calculation by z test, we can call it as z test 3, that is greater than 1.96, and even it is also greater than 2.58. So obviously it does not match once again both the values, even though all the values are clearly given in the statement, because no extra calculation we are done. Then the 100% declaration, 100% sure the factory is not working as per standards. That means easily you can manage when z equal to 3 means it exceeds both the critical regions. One critical region is 1.96 and minus 1.96, another critical region is minus 2.58 and plus 2.58. In both of these limiting values, this z equal to 3, but that means if it is asked at 5%, then you have to go for first critical region. If it is asked at 1%, then you have to compare with the second critical region. Therefore, 3 comes completely exceeds both of the limits. Therefore, easily you can declare the person who is selling the sugar as standard value like 100 kg in a bag. That means he is not selling 100 kg in a bag. It may be less than 100 kg. Some bags, because a sample of 144 bags, it is taken and it is tested, the average mean as that is 99 kg per bag. That means 99 kg per bag means it may be 99 in one bag, or it may be 98 in one bag, or it may be 100 in one bag, but the average mean gives 99. That means, for example, what is the benefit? See, what you have to expect in the common observation as, that means 144 bags when it is taken as a sample in a factory, that when even from 144 bags, if the weight is not properly maintained, that means the benefit goes to the person who is owning that factory, but not to the person who is going to buy the sugar. That means he will be put under loss, and the owner which he sells the sugar, he will get the benefit by making all these negative differences. That means it is mean value, even it may be ranging from 97 up to 100, then but the average value we can consider from the given data as 99 kg. And also the standard deviation, here also you can declare your discussion, you can give the discussion standard deviation as 4. This is standard deviation is also not up to the expected level, that is also which has got the higher value. Therefore, from these two, theoretically itself you can declare the factory is not working as per standards. So this is another situation we have taken. Now similarly, you can study all these examples which I mentioned here, then you can try these examples in your leisure time with the same principle. And the next discussion we are going to consider as sampling variables. The sampling variable are such as weight, height of human beings, weight of certain articles, like that also you can take, and height of the plants also in biology you can take, and each member of the population gives the value of the variable, and the population is a frequency distribution of the variable. Thus a random variable, a random sample of size n from a population is same, selecting n values of the variable from those of distribution. What is the sampling variable? Why this is sampling variable in terms of heights and weights? Because if you consider human being, for example, if you consider human being means the height and the weight, that means these two are continuously changing up to certain age, even after certain age also. That means from the child when it takes the birth, and when that particular human being makes a death, then till before that time you can see all these changes, therefore it is continuously varying. Then if you take a sample of some group of such human beings, and then if you study the behavior, then you can induct the variable symbols in terms of samples which you are going to draw for statistical discussion. It is called sampling variable. Then sampling distribution of mean. Sampling distribution of mean, you will be studying what is the mean of this sample you are going to take, and how this it is distributed normally. Once again, that normally means symmetric distribution. Its behavior will be studied with the standard error as standard deviation divided by square root of, that is a given number, or sample size, that is sigma divided by square root of n. And confidence limits for unknown mean. Confidence limits for unknown means, already I had told you that there are two critical regions, that is mean plus or minus 1.96 into standard deviation divided by square root of total number it is given, and mean plus or minus 2.58 standard deviation multiplied by, that is standard deviation divided by square root of number, that is sample size. Then here we consider some situations how this declaration is to be done from the hypothesis point of view. That is, here one concept we introduce, that is called degrees of freedom. In this degrees of freedom means whatever the total value of n is there, that n, if you take one number less, that is called degrees of freedom. If n is equal to 10, then you have to introduce that degrees of freedom which we are going to include in the next test as n minus 1. Now the very important another statistical procedure to verify the data which is to be rejected or accepted in terms of degrees of freedom. There is a great mathematician who is called as a student, and he invented one kind of test, and it is called as distribution in terms of he has designated that test as T. That is, T is equal to sample mean minus population mean divided by, that is standard deviation in terms of degrees of freedom, and multiplied by square root of n. This is called student T test. It has been named as student T test. Let us discuss what are the properties of this student T test and how this equation is going to be applied in various situations of this sampling theory. That means student T test the expression directly I am taking, that is should be taken as under modulus, because in some calculations you are getting it as negative value. Since T has is representing the magnitude, then we measure it in terms of the positive signs. Therefore, that is x bar minus mu divided by sigma and square root of n, square root of n, where x bar is equal to sigma x divided by n, and mu the population mean and this is sample mean. In every situation you have to list all these values when you come across to apply t-test for the declaration of the hypothesis which is to be rejected or accepted. Then sigma, this sigma here in terms of degrees of freedom, the short form we write it as df, and this is equal to square root of sigma x minus x bar whole square and divided by, instead of n you have to put it as n minus 1. In the normal calculations what we do for finding this standard deviation, square root of sigma x minus x bar whole square divided by n only we put it, but in this test in terms of degrees of freedom, because you have to write n as one number less, therefore as I told you that if the total number is given as n, then in terms of degrees of freedom you have to take in the denominator as n minus 1, and another one is this n is the sample size. So you have to remember these four values very importantly, and accept the data in whichever the situation it is given. What is the value of x bar? If it is given, write it. If it is not given, then you calculate. Then mu, if it is given, you take that numerical value. If it is not given, then you have to read the statement whether that population mean has got the value as 0 or some other value you have to represent, and then calculation of standard deviation. Then don't do any mistakes in this calculation, because you have to attach in the denominator, that is in terms of degrees of freedom. That means in the normal calculation in general you will write sigma of x minus x bar whole square, that means each value of the statistical variable minus of its arithmetic mean whole square divided by n minus 1 you have to write. Then n is the sample size. When you write all these terms properly from the given statement of the application problem, then you have to write modulus of t using this equation. So what that value gives, we will be getting in the calculation of the next few problems which I am going to discuss. Then two situations once again you will declare, that is t at 0.01 and t at 0.05 respectively. This t at 0.01 will be, that is between 2.58 and minus and plus 2.58 critical region, and here this gives, that means this is at 1% level of significance and this is 5% level of significance. That means this is nothing but 1.96 with minus and 2 plus 1.96. Here also we take these two, but the symbols we are going to use in declaring the value of this t-test, whether it is given t suffix 0.01 or t suffix 0.05, because you should not get confusion when you are going to collect the value from the table, because you will get totally three types of tables. One is values of t-test, that is t values you are getting, and values of chi-square test. In the next discussion I am going to take chi-square test, their values of chi-square as standard values, and another one is values of f-test, which we are not going to discuss in this topic. That is, there are three tables, but in each table, like these suffixes will be given by those suffixes itself for in each situation of the application problem. If this value is mentioned, for example t at 0.01, then you have to follow the critical region as minus 2.58 and plus 2.58, and then 1% level of significance, which gives the declaration in this region, and t at 0.05 gives between minus 1.96 and plus 1.96 as 5% level of significance. This is the very important equation that we apply in many of the application problems, whether it is related to engineering or any other topic, but this test normally gives very appropriate decision in making the hypothesis which is going to be accepted or it is to be rejected under what degrees of freedom. that degrees of freedom, in terms of degrees of freedom you have to write the equation. Then what are the properties of this t distribution? Here also we compare the given data in the form of a standard normal curve, as I told you. This is standard normal curve. The very first property of t distribution also takes it is a bell shaped curve. That means already I told you that if mean, median and mode, if all these three are same, then only you are getting this normal distribution curve. That means on either sides the area is equal. Then always in the case of data which is not normal, then always the mode will be the maximum height, like this you are getting. That means more area towards right side. This is called positively skewed data. In this case the maximum height is mode, and the second one height is median, and the third one is, that is mean, arithmetic mean. Similarly, if you see in the opposite direction towards negative x axis, then maximum number of items are lying towards the left side. In that situation, this maximum height will be mode, and the middle one will be median, and the third one is arithmetic mean. This is negatively skewed and this is positively skewed, and here there is no skewness. That means skewness equal to 0. That means all the three values coincide. For example, mean is equal to something like 12, and median is also 12, and mode is also 12. But here mode is, if it is 12, somewhere median may be 11 point something, and mean is also 11 point something or 10, like that. That means they must be in that particular order. So we say that it is both of them are not normal curves. The first important property of this t distribution, symmetrical about the line t is equal to 0, and like the normal curve. Like the normal curve means this is the information which you have to remember. It is equally distributed on either sides. When it is not equally distributed, more items towards one side, that is positively skewed and negatively skewed. Because in any data, if such concept is included, then you cannot apply that t-test when you say that the data is normally distributed. Then since only even powers of t appear in the equation, that means when you write the probability density function of t-test using probability density function, and the even powers we consider in the expansion, and then we declare, that is whether it is coming under normally distributed or not coming in the normally distributed curve. Then here you can easily identify which is a normal curve and which is a t curve. Almost the polynomial equation, the curve for the polynomial equations will run parallelly. This is t curve and slightly deviate from the standard normal curve, and the normal curve is, that is equal distribution, and this curve along with the normal curve it flows and it comes to the starting point, and ending point will be the same almost. If there are any questions, you can ask, then I'll answer.